All right, class, today we're going to be looking at express the functions with a positive acute angle. Well, expressing the functions of trig functions with a positive acute angle. So what do we mean by that? So we're going to be looking at, first of all, the cosine of 157 degrees. So we're going to rewrite this as a function with a positive acute angle. 157 is not an acute angle. So going back to the unit circle, drawing angles in standard position, we want this angle to be less than 90 degrees. Acute angle less than 90 degrees. So what does that mean we have to find? In these problems that you're going to be doing in your homework and these three examples that we do, we need to know what's the reference angle. And the definition of a reference angle is the acute angle measured from the x-axis. Never, never, never the y. Always the x-axis. The acute angle measured from the x-axis to the terminal side. Okay, so what does that mean for 157 degrees? All right, number one. Or am I going to do this? Number one. Draw the angle in standard position. Draw angle in standard position. Why do we do this? Once we draw the angle in standard position, we'll know where the acute angle is, we'll know how to find the acute angle, and it'll tell us what quadrant we are in. So here's my axes. Remember, when you draw an angle in standard position, this is a positive 157, so we have to go counterclockwise. This is 0, this is 90, this is 180, this is 270. So we are more than 90, less than 180. So there's my angle drawn in standard position. So that right there represents 157 degrees. This right here is the reference angle. And in order to find that reference angle, we subtract from 180 degrees, because this is 180, this is a half a circle, a straight line, so 157 minus 180, and that gives us 23 degrees. Okay, so number two, find the reference angle. We did 23 degrees. So now number three, rewrite function with the reference angle. So cosine 23. And then number four, we apply what we picked up in the last lesson, the ASTC. What do we know about cosine in quadrant 2? Well, cosine in quadrant 2 is negative, so that means we put a big fat negative sign in front of this answer. So we're looking at negative cosine of 23 degrees. Okay, so we did that without the calculator. I could have typed this into the calculator. It would not have given us 23, but we could have typed in cosine of 157, and we would have noticed that this angle was negative. Okay. As long as I'm in degree form, which I am, cosine 157, cos of 157, I know the answer is negative. Negative. And there is the acute angle. That's all I want you to do in this piece. In the homework, that's all you're doing on the first 8 or 9 questions. Okay, let's look at another one. Sine of 213 degrees. All right, draw the angle in center position. Where's 213? Well, this is 180. That's 270. Well, hopefully you're smart enough to know 213 is in between these two spots. Close enough to me. So there's my 213. The reference angle is measured from the acute angle measured from the x-axis. So x-axis, acute angle. So here is my reference angle right here. Reference. Again, well, there's 180. I'm a little more than 180. Well, how much past it? I got to subtract. So 213 minus 180. And that 33. Okay, so found the reference angle. Check. Rewrite the function with the reference angle. Sine of 33. And now, what do we know about the sine in quadrant 3? What do we know about sine here? Remember, sine is the y value, and y's are negative. Y is negative down below the x-axis. So this is a negative sine of 33 degrees. Done. All right, last one. Tan of negative 48 degrees. Uh-oh. Negative 48. What does that mean? Remember, positive angles we draw from the initial side. We always draw counterclockwise. Negative angles, we're going to have to draw clockwise. So then, now wait a minute now. We got to be smart here. This is 0, 90, 180, 270. This is 360. Where's negative? Well, all we do is go backwards. So if I go backwards, remember each of these quadrants are right angles. They're 90 degrees. 90, 90, 90, 90. So here's 0. That's 90. So 48 is right here. That's 48 degrees. Okay. Now, what's the reference angle? Remember, the reference angle is always the acute angle. Well, 48 degrees is acute. We're done. Now I'm going to rewrite my function with the reference angle. So we're looking at tan of 48. And now, what do we know about tangent in quadrant 4? Well, ASTC, the only thing that's positive in quadrant 4 is the cosine, so therefore this is a negative answer. I know I did a lot of negatives here. Okay, I just wanted you to see where I wrote the negatives. If this was a positive answer, then it's just a positive answer. Okay? For example, if this was sine of 157, this would have been a positive value. Okay? Okay, so this is what you're going to see in your first 8 or 9 questions in your assignment. Okay? The next piece, we need this information in order to do the next piece, as to how to draw the angles in center position. So the next piece is special angles and their exact values. Oh, wait a minute now. What do we mean by special angles, and what do you mean about their exact values? We have 7 angles that we have exact values for. Okay? We have 7 angles that have exact values. Seven main angles. The first 4 are your quadrantial angles. So your quadrantial angles, those are your angles of the 0, the 90, the 180, the 270, and if you want to say it, 360. If you want them in radian form, these are your degrees. You want them in radian form, 0, pi over 2, pi, 3 pi over 2, 2 pi. Radian form. These are your quadrantial angles. Okay? That's 4. That's 1, 2, 3, 4, 5. That's 5 of them. Oops, there's 8. Because I added in 360, which is the same as 0. Okay, your other three, the other three are your 30, your 45, and your 60. If you remember your Algebra 2, okay, these right here you can get from the unit circle. Some of you memorize the unit circle. I like to teach memorizing special triangles. I have two special triangles. One is a 30-60, and the other is a 45. That's an isosceles triangle. This is 45 up here as well. So in a 30, 60, 90 triangle, the dimensions are 1, 2, radical 3. And in a 45, it's 1, 1, radical 2. So now if I want the sine, cosine, or tangent of any one of these angles right here, 30, 45, or 60, all I need are these triangles. Sine of 45, well, 45, sine of 45. Well, sine of 45, opposite over hypotenuse, 1 over radical 2. That's your SOHCAHTOA. And then you can leave your answer like this, but I think you're going to be better off converting it, so rationalizing the denominator, so radical 2 over 2. Remember, for those of you that don't remember that, all we do is multiply top and bottom by radical 2. So we have 1 times radical 2 times radical 2. So radical 2 over 2. Okay. If I wanted the cosine of 30 degrees, here's my 30, 60, 90 triangle. Well, cosine of 30, well, here's 30. Cosine, AH, adjacent over hypotenuse, radical 3 over 2. Okay. If I wanted the tangent of 30, that is opposite over adjacent, 1 over radical 3. And again, rationalize this, it may make your work easier. So we multiply top and bottom by radical 3. So we have radical 3 over 3. Okay. All right, so now what does that mean for us? We're going to find exact values. I'm going to start with the sine of 135 degrees. All right, I thought we only had 8 of them. Well, 30, 45, and 60 are in quadrant 1 of our unit circle. Here's your 30, your 45, here's your 60. No, then don't forget we have all of the other quadrants that we could find that have the references of a 30, a 45, or a 60. Okay, this is all part of that unit circle. Some of you saw your unit circle like this last year, where you had to memorize all of those spots on the unit circle. And it was your 30, your 45, 60. Then this would be 120, 135, 150, then 180, so on and so forth. Some of you learned that last year. All right, I'm doing this. I like the triangle method. Okay, less to memorize. If I know my triangles, I can figure out the reference angle, and as long as I know what quadrant I'm in, I'll know if the answer is positive or negative. Okay, and if you're not sure if your answer is positive or negative, type it into the calculator. Okay, I want exact answers though, not decimal answers, exact answers. All right, so first of all, what do we have to do? Well, we need to find the reference angle. So I'm going to start by drawing the angle in standard position. 1, draw angle and standard position. Two, find reference angle. We don't have to rewrite the function. We just have to evaluate it. Evaluate the function at the reference angle. And then number 4, apply our ASTC. Okay, so all right, sine of 135. Well, draw the angle in standard position. 135. Well, that's in between 90 and 180. Well, 135 is right there. The reference angle is right here. There's your reference. So 180 minus 135 is 45. So we're looking at the sine of 145. Well, here's 45. Sine is 1 over radical 2. So we know the answer is 1 over radical 2. I don't want 1 over radical 2. I want you to rationalize. So this becomes radical 2 over 2. All right, now, number 4, apply ASTC. What quadrant is this? This is quadrant 2. What do you know about sine in quadrant 2? The y values are positive. Remember, anything above the x-axis is positive. That's this right here. So this is positive. That means we're done. Okay. Cosine of 150 degrees. All right, let's draw the angle in standard position. Here's 150. There's 90, there's 180. Looks like 150 to me. Here's your reference angle. Again, subtract from 180, we have 30 degrees. Here's my triangle, 30. Cosine of 30. Adjacent over hypotenuse, radical 3 over 2. Well, now the only question is it positive or is it negative? And what do we know about cosine in quadrant 2? It's negative. Remember, the x-coordinate is negative on left of the y-axis. There. Nice, easy questions. Let's do a few more. Tan of 210 degrees. Okay. Draw your angle in standard position. 210. Well, there's 180. Here's 270. We're in here somewhere. Here's the reference angle. So all I have to do is subtract from 180. That gives me 30. So we're looking at a 30-degree angle. So what's the tangent? I'll put it over here. So what's the tangent of 30 degrees? Well, here's 30. Tangent of 30 is 1 over radical 3, TOA, opposite over adjacent. So we're looking at 1 over radical 3. I want you to rationalize that. Some of you will just memorize. Now, what do we know about tangent in quadrant 3? ASTC. We have to know if this answer is positive or negative. This is good. Knowing this is half the battle. Now we just have to say plus or minus. Well, tangent is positive down here, so we're done. Okay, we just did a bunch of them just in degree form. Let's do a couple more in radian form. So I think what I'll do is I'll redraw the triangle. 1, 2, radical 3. Remember, the hypotenuse is always 2 in the 30, 60, 90. 1, 1, radical 2. Okay. So cosine of 3 pi over 2. Uh-oh, here we are in radian form. Now what do we have to do? So if you remember from last year, in order to convert radians to degrees, you have to multiply by whatever the radian value is times 180 over pi. So here we are. All I have to do is take this and multiply by 180 over pi. Through miracles of modern mathematics, the pi's cancel. 2 goes into 180. 90? 3 times 90 is 270. Uh-oh. What the heck is 270 degrees? You need to recognize this as a quadrantial angle. That's a quadrantial angle. Remember that? Quadrantial angle, 270. So what is the cosine of 270 degrees? We get that from the unit circle. Remember? Your ordered pairs, 1, 0, 0, 1, negative 1, 0, 0, negative 1. Cosine of 270, 0, 90, 180, 270. Cosine is the x, so cosine here is equal to 0. So this answer is 0. Okay. All right. So don't forget your quadrantial angles. All right. Do not forget your quadrantial angles. If you see a 0, a 90, a 180, a 270, a 360, don't forget about those. Don't freak out. Just do it. It's not hard. Okay. Sine of 5 pi over 3. All right, here's another one. Now, I'm going to give you a hint right now. Anytime that you have a denominator of 3, it is going to be one of your 60 degrees. It's going to be a 60 degrees. The problem is what quadrant, okay? So, do my 180 over pi. Pi's cancel. So 3 goes into 180, 60. So we have 300. Draw your angle in standard position. 300. Remember, here's 270, here's 360. So that we're looking at leftover. I have to, since I'm in the fourth quadrant, I'm going to subtract from 360. So subtract from 360, we have 60 degrees. So I need the sine of 60. Sine of 60. So this is a 60-degree reference angle. Sine of 60. Opposite hypotenuse. Radical 3 over 2. Now my only question, what do we know about sine in this quadrant? Again, sine is the y value. The y's in this quadrant are negative. That's your ASTC. All right, last one. Cosine of 7 pi over 4. Now I'm going to give you another hint. Anything with a denominator of 4 is going to be your 45s. It's going to be a 45. The question is, we just need to know what quadrant we are in. So let's find the official angle. We'll figure out the reference. So 180 over pi. So 4 goes into here, 45. So we're looking at 315. 7 times 45 is 315. And so again, I'll draw the picture. 315. So here's the reference. So we have 45. And remember, This was 360, that's 270. So all we have to do is 360 minus 315. Gives us 45. All right, cosine of 45. 45, 1 over radical 2, which we know is radical 2 over 2. Okay, we're talking cosine. Is this positive or is this negative? ASTC. Cosine's your x. X's are positive on the right side of the y-axis. So positive, radical 2 over 2. All right, so those are the types of questions that you're going to see in this assignment. Okay? All right, good luck.